And you can read it if you go to Professor's Scholar page, and you can find that it will be there. So this is another idea. This is another place where I said conventional things don't work, and smart materials, especially piezoelectric materials, become a viable option. And this can be extended. This kind of actuators can now be taken for even this can be extended for helicopter blade actuation or wherever. So that this is other place where this is one place where it has been used for some mechanical problem, which can be taken to the aerospace industry or something. So the next phase of that was the active control. So I'll just give a few more slides. So before I bring it to a conclusion, before I close it up. So the actual study itself was that we have to find an actuator to actively control the vibrations. So once we have this actuator, we want to show that we can control we can reduce the vibrations with active control loops and all that. So I think I'll just this slide as on how active vibration control works in case someone is new to this area. Passive vibration control is like where there is vibration, you try to take the energy out of that system, or you try to modify the dynamics. So like this vibration absorbers, how they work, you try to modify the dynamics so that your resonance frequency moves away from your excitation frequency. Active vibration control, on the other hand, is something different. There is suppose your beam is here, there is an external force which is causing the vibrations. So what you are trying to do in active vibration control is you sense that response of the beam, so which is caused by the external force, and then there is a control law which you apply, and which will control law which modifies the output which takes the output and modifies it such that you can apply a counter force which will force which will counter the original force. Meaning there is a structure, you apply a certain force, a structure which is vibrating because of certain external force. You do not know what the external forces are, but you know the response. You take that response, you do something which is the control law, and then you feed it to another actuator which will apply certain force to the structure that will result in the cancelling the vibrations from the original force. So that is in a very simple way active vibration control. So we wanted just to show that it works. So we took the one of the most simple control laws, the velocity feedback control. So yeah, this is the complete experimental unit. You have your structure here, and for actuation we used a shaker itself. There is a small shaker we have kept here, and that will be picked up. The response will be picked up by the accelerometer, and then there's the control law, everything, and and then given to the power amplifier and all that, and then you give it back to the patches to these designed piezoelectric actuators to control the vibrations. So yeah, this is once again that structure, and which is actuated, and your piezoelectric sensor picks it up, and you this is the control law here where we apply it, and then so we at that time when this was done, we did not have this digital control thing, so I had to actually use whatever charge amplifiers to integrate it and convert it from acceleration to velocity and invert it and all that. So it was something like a manual controller kind of thing, and then feed it to your control actuators. So yeah, so these are the results. So it's actually a sinusoidal signal, and it is very compact in the sense it's very high, frequencies around 900 hertz, and over 25 seconds. So this is your original signal, like where there is no feedback upright. But then once I start the feedback, once I apply voltage to the, once I pick up the original signal and do some control, and then control loop like velocity feedback control, and then apply it to the patches. And if I keep on increasing the excitation voltage to the patch, you can see the amplitude of vibration keeps decreasing. The velocity measured keeps on decreasing up to a certain point, because there is something called control and observation spillover and all that. So that leads to instability. So those things will be addressed later. So currently we just wanted to see it works. So yeah, this is the control for sinusoidal signal. Next with the chirp signal. So this is the original signal, original response. The first two sort of cycles. And once I apply the control and increase the amplitude of the amplitude of voltage to the patch, you can see that you can see this amplitude of this bracket, it keeps on decreasing on and on. So that is we wanted to test it for a couple of different types of signals. And then I used two actuators sequentially, so that this is up to first actuator, and there is some instability. Once that instability sets in, I thought I'll stop there and then use the second actuator to get like around 40 to 50% reduction in vibration. So in a nutshell, this is a couple of works. We have done other works as well, but they are more of academically inclined rather than which has direct practical implications and all that, direct practical applications and all that. So we wanted to show these two projects alone, so that people can appreciate the piezoelectric these actuators, how it can be used, and how better and its features are when compared to conventional actuators and all that. And they are cheap and all that, like you can get the whole thing within like some 40,000-50,000, but or maybe all these actuators will 2 lakh rupees. But if you have to go for conventional exciters and all that, they cost like 15-20 lakh rupees actuators, like this electrodynamic shakers and all that. So yeah, that is it. Thank you. If you have any questions, please ask. Feel free to ask. Hello. Hello.
Yes, sir. Hello.
Yeah.
Please.
Oh, was I there or not? I mean,
You were there. You were there.
oh, okay.
Yeah.
I thought I was talking, and then that maybe it went offline. I am just talking to the computer. Right?
No, no. That's what is happening most of the time. We
Oh,
are lost.
I
Yeah,
mean,
sure. You are there.
were you able to listen till the end of the presentation, or did the line go off in between?
No, no, sir. We were able to listen.
Oh, okay, then, fine. If there are any questions, please, yeah, you can ask.
Any questions from the participants? You please make first. Hello. Okay, very interesting session, and it motivates me to focus on this area. Thank you, Dr. Guru Sudeshwar, sir. Okay. So any questions from the participants? I think there are no questions, sir.
Okay.
We have. Okay. So we have come to the end of the session. So as we are progressing into it, we are finding that nanomaterials and smart materials, nanocomposites and smart materials are finding their application in all the fields. So yesterday we had a session in data storage devices, and today it is on electronics. So this is really very interesting to see that, because materials previously it was thought it is mechanical only. Right. Thank you, Dr. Shiva Shankar, sir, for your presentation and the valuable time.
Yeah, thank
Hello.
you. Yeah, thank you.
Yeah. And also, I would like to I would like to thank Dr. Professor
Yeah, Professor Gopalakrishnan.
Professor Gopalakrishnan sir for recommending you.
Yeah,
Yeah, convey my regards.
yeah, thanks. Sure.
Actually, Ramesh is there, right? I think you know him. He's
Yeah, yeah.
working with, yeah, Ramesh is my student at MRSET, at undergraduate.
Oh,
So through him I approached, sir.
okay.
So thank you very much for your time, sir.
Yeah, thank you.
So we
Then I'll
continue,
be, yeah,
yeah,
I'll
we
be off then.
continue the same. Yeah, we
Yeah,
continue the same
thank you.
in future
Yeah,
as well. Thank
okay,
you.
thank you.
Thank you. So the feedback link will be posted in the afternoon session only. So we can attend the afternoon session. We are having with Dhanajayan live session on ANSYS training. So we can meet in the afternoon at 2 o'clock.